Welcome. In this video, we're going to go over some curves and determine whether they're simple or not simple, closed or not closed. The first two we're looking at, I have graphs already. And so this one starts at a point, ends here, and it doesn't overlap itself. It never crosses over itself, so it's definitely simple. However, it doesn't actually meet, start and end at the same place, so it's not closed. Now this next one, it's really clear to see it overlaps right here. And also does not start and end at the same place. So it is not simple. And it is not simple due to the overlap. So that overlap means it's not simple. And then the fact that it doesn't start and end at the same place means it's not closed. Alright, for this next video, we're just given the definition of the curve. So we're given its x component, its y component, and the limitations on t. We're going to need to graph this using GeoGebra. As you can see, I went ahead and opened GeoGebra on my iPad here, and I'm going to type in the word curve right here. And then I'm going to open a parentheses and type in my x component of 3t squared, right arrow to move over, then cosine squared, and then t, then a comma, then your y component, sine squared t, then a comma, and now I'm going to let it know what the parameter is. The parameter is t. Then the lower bound of the parameter is pi over 2. You can just type in the word pi and it will fix it for you. And then comma, and the upper bound of the parameter is 3 pi over 2. Now, this isn't really helpful, so let's move graphics. So I clicked here to move graphics view, and I'm putting my two thumbs together by the origin and moving them up away from each other. Now I'm putting my thumb and forefinger against the x-axis and moving them towards each other. And now let's just move this whole thing. Here we go. There is our region, and I want it to look a bit like the others. So let's tap this now and change its color to blue. There we go. Okay, so now here we have the definition of the curve and the graph of the curve together. Those of you taking my class, please copy and paste a screen grab or print this out and then paste it onto your notes, or even sketch it manually. But if you sketch it, make sure you use a ruler and be precise, please. So this curve does not overlap. So it does not overlap. That means it's simple. And then we see that it starts and ends at the same place. So that tells us it's closed. Alright, so we've finally made it to the last curve here. And again, we're not given a graph, we're given that the x component, so this I component here, is sine t times cosine t. The j component, y, is t squared sine t. And the k component, z, is sine t cosine t. And our parameter t is bounded between negative pi and pi. So let's go back to GeoGebra. Here I am back in GeoGebra, and you can see I'm still on my last curve, so I'm going to select the menu and go New, and I'm going to discard my changes. And it brings up a new GeoGebra Classic window. I'm going to move my finger over 3D Graphics and tap that, and here I am on 3D Graphics. The red axis is the X, the green axis is the Y, and the blue axis is the Z. Personally, I like to hide the XY plane. I think it makes everything easier to see. You can leave it if you'd like. So to show it or leave it, you can tap on these options here. Okay, so now let's go ahead and tell GeoGebra what to graph. So I'm going to type in curve, and then for the X component, sine t, cosine t, comma, move on to the J component, that is Y. So t squared sine t, lowercase t. If you make it a capital T, it'll treat it as a constant and provide you with a slider, so don't do that. And then our last z, that is the k component of this vector valued function, or this vector field, is sine t cosine t. And then our parameter t, and then we go from negative pi to pi. And in my haste, I might have said vector field. We have a vector valued function. Right now, at this view, it's not really helpful. I don't see much. I just see some squiggly lines. So I'm going to tap here on this rightmost icon and click Rotate 3D Graphics, and here we go. I'm getting a much better view of it now. If I view it from below the XY plane, or even at an angle here, oh, this is a really nice view. I can see this region a lot better. We can also tap on the same icon, move graphics view, and see how those arrows pop up. If I go and tap the screen once, it makes them vertical. Now start with your thumb and forefinger at the origin and then spread them apart to make these axes grow and shrink. There we go. Okay, and I think this is a pretty good view here. Now I just want to make my axes a little more understandable. So there we go. Actually, one more thing. I don't like that it's not showing the whole thing. There it is. Okay. So now I'm going to go ahead and take a screenshot. You do the same, those of you in my course following along. So you can see now I have both the definition of the curve and the curve graphed. I'm going to quickly just label things. This is my x-axis, this is my y-axis, and this is my z-axis. And it's not oriented in the way we're accustomed to, so it's definitely a good idea to have it labeled. And then our curve C is here. So first thing I notice is there's this overlap here. So that overlap tells me that the curve is not simple. However, notice there are no gaps. I could trace this out continuously, telling me that it starts and ends at the same place. So this starts and ends at the same place. More formally, if I say this here is r of t, more formally I can see that r of negative pi is equal to r of pi. That is, it's the same value at each of the endpoints, so it is certainly closed. All right, please keep calm and math on.